A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm the same. Thank you. Any doubts that you have from the portion that we have covered in the last weekend? In case you have covered that portion on your own or you have tried to cover the portion on your own, any doubts that you have, feel free to ask. I'm good. Thank you. We'll be starting the session in a couple of moments, guys. Parshuram, yes, that will be sufficient. The 11th and 12th, all the NCRTs which are there, that would be sufficient for your basic reading, yes. So the class notes, the PPT, etc., all the discussions that we carry on in the class, supplemented with the NCRTs. Many of the discussions that we are going to have, you will not find to be present in the NCRTs, but then there are few nuances, few of the data pointers there in the NCRT. Supplement it with the NCRT after you have covered the class, after you have studied through the class. NCRT should be very, very easy to cover. You won't find much of a difficulty in coverage of that NCRT at all. It would be something which you would be able to finish within at max 7 days to 10 days if you are concentrating properly. So there, use that, and then current affairs is always going to come to your rescue. Okay. Seismic waves, Priya, basically these are the, whenever you have an earthquake which occurs, large amount of energy is released in the process, and that energy travels in the form of wave like pattern, and that is what we regard as the seismic waves. Now when we talk about these seismic waves, they end up traveling from the region of the focus throughout the various different parts. So seismic waves, when they travel through the body of the planet Earth, that is what is referred to as the body waves. But when that energy is transversed, or when that energy is emitted, now that energy will also end up impacting the surface. And once the surface is impacted, there is a wave like formation across the surface as well, which travels in the outward direction, and that is what we regard as the surface waves. Okay. Last week earthquake happened in Nepal and Delhi. See, the earthquake happened in Nepal. The impact was felt in Delhi. The epicenter was in Nepal. And the reason of it is always very simple. When we talk about the region of the northern part of the country, be it the earthquake which has occurred in Nepal or an earthquake which occurs in Assam, Arunachal, Uttarakhand, Jammu Kashmir, in the entirety of the region, the reason is very simple. You have the convergence of plates which are happening in that area, and that is why the earthquakes are caused in that area. Okay. Hello, sir. I've started reading NCRT in the section of minerals. There's a concept of which is we will cover it when we talk about the minerals and industries. We'll cover that up. Okay. You can, or otherwise, you can do one thing. Send the snapshot of it on mail, and I will help you understand that in a better manner. Okay. So, hello, a very warm good afternoon to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session and another weekend of geography, where today we shall be proceeding ahead with the portions and the concepts that we had laid last weekend. and thereby we are going to cover the rest of the portion of geomorphology. And in this weekend, we shall also be proceeding to the next big module of geography, the next big unit of geography, and that is the portion of climatology. So that is something that we are going to cover in the entirety of this particular weekend. Okay. Now, here, when we talk about what are the portions that we covered last week, and we initiated the discussion with the basics regarding latitudes, longitudes, international dateline, the occurrence of seasons that we experience, why do we experience all these various different types of seasonalities. Then after that, we proceeded ahead with the aspect of the interior of the planet Earth, where we studied about the internal structure, where we observed that the portion that we live on, that is the thinnest portion of the planet Earth, that is known as the crustal region. And then you have very thick mantle, and inside the mantle you have the molten outer core, and inside the molten outer core you have the solid inner core. We looked at the fact that the inner core continues to remain in solid state despite very high temperature because of the humongous pressure which is imposed in the region of inner core from all the surrounding areas. Now, in the inside of planet Earth, we have seen that ever since the time of formation, the inside of planet Earth has got substantial amount of heat which is trapped into it. Now, that heat, time and time again, keeps on getting released from various different portions and various different pattern, which can generate a convective current inside the mantle as well. And that is responsible for many of the different activities on the planet. All the forces which are acting from inside the planet Earth, they are also together what is referred to as the endogenic forces. The forces acting from the interior, that is what is referred to as the endogenic forces overall. Then after that, we moved ahead and we moved forward with the portion of when we tried to understand the origin of continents and oceans, where we looked at the continental drift theory, first of all, that what is that continental drift theory all about. And it was basically propagated and postulated by Alfred Wagner. And Alfred Wagner talked about the possibility of the continents moving from one place to another. He talked about the aspect or the possibility that at one point of time in the history you had a giant supercontinent which was named as Pangea, and that Pangea basically split into two portions, and that is how you had the creation of Gondwana land, consisting of the continents, present day continents of South America, Africa, then the Arabian Peninsula, India, Madagascar, Australia, and Antarctica. All of that was present in the portion what we regard as the Gondwana land. And the portions to the north included the regions of the present day Eurasian continent and also North America. Now, even after that, the continents, they basically drifted away from each other to give rise to the present day shape of the continents and oceans that we see. Now, as far as presenting the evidences to support his theory, that there Alfred Wagner was to the point where he talked about the various different types of evidences, from the jigsaw fit to the geological evidence in terms of the geological origin of the various different rocks. When is it that the rocks have come into existence? And also paleontological evidences, glacial evidences. So Alfred Wagner basically had managed to summarize all the various forms of evidences in order to postulate his theory. But when it came the time to give reasons, why is it that the continents are drifting? That is where Alfred Wagner faltered, because he was a meteorologist, a climatologist in a way, and he did not specialize in the internal structure of planet Earth. So that is where the continental drift theory was rejected at that point of time. But nonetheless, the very idea that the continents could be drifting with respect to each other, that significantly gained traction, that significantly gained ground, and that led us furthermore to understand the plate tectonic theory, which was postulated almost 40 to 50 years later as compared to Alfred Wagner. Now, here, when we talk about the other theories which also led us towards the direction of the plate tectonic, you also have to talk about the convection current theory provided by Arthur Holmes. And there, Arthur Holmes talked about that how heat in the interior of the planet Earth, that heat in the interior travels outwards, that is the residual heat, and that travels outwards in the form of the convection current. And when that convection current is generated, that can end up having a vertical column as well and a horizontal column of that convection current as well. The vertical column can give rise to upliftment of land masses, emergence of volcanic eruptions in certain cases, and it can weaken the land in certain areas. But when we talk about the horizontal direction of the convection current, it always can tend to pull the lands apart. Now, Arthur Holmes did not provide any further supporting evidence that yes, indeed, the continents are behaving in such a pattern. But then he talked about how the heat is transmitted from inside to the outside. Further, another theory which was generated immediately after the Second World War was the seafloor spreading theory, which was postulated by Harry Hess. Harry Hess, upon looking at the seafloor, upon observing the seafloor, he did observe that there is still the presence of active volcanism around the region of mid-oceanic ridges, whereby the observation or the basic understanding was that you have the creation of a newer crust which is created due to these convection currents. Newer crust is created as a result of volcanic eruption happening around the mid-oceanic ridges as the older crust is getting pushed aside. So that laid the foundation of explaining how is it that the oceans, they can change their shape, they can change their size depending upon the seafloor spreading which is happening underneath them. But that seafloor spreading theory also had certain drawbacks. For example, it did not talk about whether this phenomena can happen in the oceanic areas, etc., and so on. Now, based upon all these three theories, you had various different research scholars in the name of Morgan. You also have Wilson, Parker, all of them. They together in different research papers, obviously. In the 1960s, that is up till around 1967, they submitted what is referred to as the plate tectonic theory. The plate tectonic theory basically was talking about the fact that the planet surface, including the crust and the upper portion of the solid mantle, that is divided into small parts, what is referred to as plates. Depending upon the size, the plates have been divided into major and minor plates. Almost all the major plates that we talk about, other than the Pacific plate, they would consist of both the oceanic crust as well as the continental crust. And because of that residual heat generating the convection current in the mantle, these plates, they are set in motion against one another. That motion could be towards each other, that motion could be away from each other, and there could be such kind of activities, right? So as a consequence of that, you have the plates moving towards or convergence of plates, plates moving away from each other, divergence of plates, or plates moving parallel to each other. Now, either of these activities, they can lead to creation of new land masses like fold mountains, creation of underwater very deep oceanic trenches, and also the creation and the existence of various geophysical phenomena like earthquakes and volcanoes, where we also observe that all around the region of Pacific, there is some or the other convergence which is happening, either it is continent ocean or ocean ocean, due to which there is a frequent occurrence of volcanoes and earthquakes all around the region of the Pacific, what is also regarded as the Pacific Ring of Fire. And it is along that Pacific Ring of Fire, be it South America, North America, the region of Southern Pacific around Tonga Islands, Japan, Philippines, the entire region, or a kind of a semicircle around the region of Pacific, that creates frequent volcanic eruptions and earthquakes. So these plate movements have been able to explain various different phenomena. For example, the formation of Himalayas, for example, the formation of Rockies, Andes, the fold mountains, oceanic trenches, and also why is it that earthquakes, volcanoes, they do occur. Now, after that, we try to understand and implement and apply the portion of plate tectonics in order to understand that how the Himalayas got created, where we observed that basically around 150 million years back, India was still very much in the region of southern hemisphere, very close to the southern pole. And then basically drifting happened, and India started drifting northwards at an accelerated speed of 15 to 20 centimeter per second. And in the process, obviously, you had the Madagascar island, which separated from the western part of India. Before that, Madagascar was very much a part of India. And then it separated, and India started moving northwards. And then As India moved northwards, between Indian landmass and the Eurasian landmass, you had a shallow sea, which was named as the Tethys Sea. That Tethys Sea underwent compression. Some part of it underwent subduction underneath the Eurasian plate, but eventually the rate of movement of Indian plate was so very high that the entire Tethyan seafloor could not subduct, but rather was compressed and was uplifted. As it actually underwent upliftment and it rose up, thereby it led to the creation of the folds, and that is how eventually the folds were created. And then the Indian landmass and the Eurasian landmass, they underwent that collision. That collision is still happening, due to which you have the creation of these multiple folds. We also observed that after every fold that gets created, eventually the rocks, they are unable to get deformed beyond a certain extent, due to which the rocks indicate a kind of an existence of a crack formation, where after they cannot get deformed beyond a point, they will get broken. And it is that movement happening across these cracks which gives rise to various earthquakes and seismic activities across the entirety of the region of Himalayas. So we got a brief preview about the regions across the country which will experience very active seismicity or very frequent earthquake activities. And there we talked about the region of the Himalayas and also the region of Gujarat. Now, while the Himalayas, they are active in terms of earthquake occurrence because of the collision of the Indian and the Eurasian plate. But when we talk about the region of Gujarat, that is active seismically because Gujarat lies at the boundary zone of three important plates, that is the Indian plate, the Eurasian plate, and also the Arabian plate. And any movement across any of these plates gives rise to earthquakes across the region of Gujarat. And this is the reason why Gujarat also experiences very high frequency of earthquakes, and that also of high magnitude. Now, all of these activities are happening due to the forces coming from the interior of the earth, and that is regarded as the endogenic force. Now, then we moved on into the portion of earthquakes and volcanoes, where we introduced ourselves to what earthquakes are. So earthquakes, basically, they are the shaking of the earth's surface. Whenever the earth's surface that gets shaken up due to internal movements, that is referred to as an earthquake. Now, whenever the internal movements they try to happen, there is always a kind of a resistance which is offered by the other pieces of rocks, and that leads to the building up of potential energy. And eventually, when, let's suppose, the plates they overcome that resistance and they go for that sudden movement, that gives rise to significant amount of shaking in the form of earthquakes, and that is what we feel. So basically, the point where that energy is released from the interior, that is referred to as the focus of the earthquake, and the point on the surface immediately perpendicular to the focus, that refers to the origin of the earthquake, that is referred to as the epicenter. Now, whenever an earthquake occurs, it can be classified based upon the damage causing ability, the amount of damage that it has created. And that is something which is referred to as the intensity of the earthquake, which is measured in the form of the Mercalli scale. Whereas the amount of energy which is released, that is measured with the help of a seismograph, and that is something that we refer to as the magnitude of the earthquake. So magnitude of the earthquake tells us about the amount of energy which is released during an earthquake. We talked about the fact that how that energy is released. When it is released, it travels in the form of energy waves. Those energy waves are referred to as the seismic waves. Now, when these energy waves they travel in the interior of the planet Earth, they are referred to as the body waves. Body waves are of multiple different types, but for the portion of general studies, we have restricted our understanding to the P as well as the S waves. The P waves and the S waves, they are the ones which basically travel through the body. Now, in the case of the P waves, when the energy is released, the particles they get disturbed in the pattern which is very similar to that of how a sound wave travels, right, in the form of compression and expansion of materials. So here in the case of P waves, you will observe that the materials they get compressed, they get expanded as well. Okay, again they get compressed, again they get expanded as well. So that is what creates these P waves. In the case of P waves, the direction of the particle movement is similar In fact, it is the same as the direction of the wave propagation, due to which not only are the P waves able to travel much faster, they are also able to basically travel through the solid, liquid, as well as the gaseous mediums if they are present in the interior. When we talk about the S waves, in the case of the S waves, the movement of the wave and the movement of the particle, that is perpendicular to each other. That is why S waves are smaller. And also because the particles, they don't get disturbed in the same pattern as the wave motion. When we talk about liquids or gases where the particles are far away from each other, then that wave motion basically dies out before reaching the destination, and that is what we regard as the creation of the S waves. So that is why S waves are slower than P waves, and these S waves basically are unable to travel through liquids as well as gases. Okay, I hope till this portion it is clear. Now we proceed with the portion of the surface waves. Okay, can you please provide some information regarding the eighth continent? Okay, the eighth continent, that is Zealandia. There has been a lot of study about it for and evidences historically in terms of paleomagnetism, which has indicated that there would be an existence of a large supercontinent around the region of New Zealand, with only 15% of the land mass of that supercontinent emerging above the earth's surface, above the water level or above the sea surface, and that is the region around New Zealand and the islands around it. So that is the larger continent or the eighth continent to the east of, to the southeastern portion of Australia, which is submerged. It is expected that at some point of time in the history, it would have been above water, but now it is completely submerged. Okay. How 95% Zealandia is submerged underwater. So, see, why is it that it is referred to as a continental landmass? Is because of the nature of the rocks, the type of the rocks that you have. So, underwater volcanic eruptions, they end up creating their own unique pattern and unique pattern of deposits. It can absolutely be possible that in certain areas, these particular volcanic eruptions would not have created that much of material that it could emerge above water. But in certain portions, enough volcanic eruptions would have occurred that some portions that you see in the region of New Zealand, etc., they would have emerged above water. So that is one of the postulations, that it has always been underwater. The other postulation is that due to the endogenic forces, the land masses oftentimes they get uplifted and oftentimes they simply sink and subside as well. It could be due to one of those reasons also that the land mass could have underwent subsidence. Across the planet, you come across many different areas where at one point of time it was a part of the continental land mass, but it has sunk down, it has went underwater and is under the ocean as we speak. For example, across the western part of India, across the western coast of India, what you see as the western coastline has not always been the western coastline of India. In fact, land extended further 120 to 150 kilometers into the region of the sea that we talk about, the Arabian Sea as of now. Almost 120 to 150 kilometers of that portion was a landmass. But then, because of various different activities, as we will study later on in the portion of Indian geography, some portion of that landmass, it broke off, it underwent subsidence, and that is why the western coastline of India is so very sharp, and there you have abrupt slopes that you would observe. Okay, so that is basically due to endogenic forces. Endogenic forces, any forces which are created or acted from the interior of planet Earth, that is referred to as the endogenic forces. Okay, transversal direction. Transversal direction basically refers to, see, linear direction is that when you have the particles which are present, each of the particles, they get disturbed in the same direction as the wave propagation. So all the particles, they are moving in a kind of a parallel manner. When we talk about the transverse directions here, this basically, this particle moves due to the disturbance in the in a different direction, and that disturbance will disturb the other particle, that will disturb the third particle. So overall the particles, they get disturbed in the form of a wave. So the wave motion is almost perpendicular to the direction of the particle motion, and that is why it is referred to as the transverse wave. It travels very similar to how you observe the sound waves to be traveling. Okay. In the past, the northern hemisphere where the continent split happened or not. Okay. So, how many of you recall the Wilson cycle that we talked about? Any of you remember what is the Wilson cycle that we talked about? Let me know if we recall that or not. No? Okay. So kindly take a look at the annotations of the PPT, guys. Okay. Do some homework from your side as well. I'm sure then you will be able to understand and picturize it in a much better way that what that particular event is. Okay. So Ganesh, have you taken a look at the portion of the Wilson cycle or not? Himadri continents come together and split, and this happens repeatedly. That is true. That is the part of what is referred to as the Wilson cycle. And also, let me tell you guys, again, you might think about to be very harsh that other subjects we are not dealt with like this. But then let me tell you guys very simply, this is not a subject that you will be able to understand unless and until you carry out the revision of the previous classes. Okay, this is not a subject where we in one class we talk about something as simple as okay the Swadeshi movement which happened in Bengal, then after another class again when we come back sit in the class we will talk about the Surat split, and again after two classes if we miss the third class we come about we will be able to understand the non-cooperation movement Lucknow session, etc. Neither is this session like what you see in polity where I have read the first class, I will just attend the classes and that will be enough. Let me be very frank, very honest. This is a subject which will be very easy if you are regular at one go. But if you are not regular, if you are haphazard in your coverage, if you are unable to revise what has been covered in the previous class, let me assure you, the concepts will start bouncing over your head. And I'll tell you what the exact mindset and how the mindset of the candidates work. The mindset of the candidates will be that right now I'm so very cramped, I have so less amount of time, so let me do one thing, let me start with a portion of history and polity. Once again I will revise geography at the end, I will start it with one go, I will cover it in one go. That is never going to happen. Ask any of the candidates who have competed for the examination, who have basically succeeded in the examination, ask them that whether a day comes in the life of the candidate where they think about it that now the preparation is complete, now I can start my revision. That day will never come, even if you are one day before your interview process. So that day will never come. If you are unable to revise, then this subject will be the hardest subject that you would have come across, because learning things won't make sense, concepts won't give you any particular idea in that case, and eventually you would be scampering for certain shortcut notes, certain map pointing notes, etc. before the examination, that one or two questions I will get it correct and that is it. So please don't have that approach. If you are spending all that time and energy, in case you are spending all that time and energy, and if you are serious for the examination, there is no reason why that after spending so much time attending the classes you should allow it all to go to waste. So don't let that happen. Please revise it. We deal with certain very important concepts, we have dealt with certain very important concepts that you don't find in your regular books, and those concepts questions are oftentimes asked in the examination. So please take it seriously. Unless and until you take it seriously, the subject will not take you seriously. Okay. And yes. So Ganesh, to give you the answer, in the past northern hemispheres where the continent split happened or not, yes, it has happened multiple times in the past. Even before the creation of Pangea, it has happened multiple times in the past. Okay. Just a couple of moments, guys. Okay, so let's do one thing. Let's tackle the question which has appeared in the prelims 2023. Let's tackle that PYQ. Let's get an idea about it. So PYQ of 2023 prelims. Okay, so it was a statement based question, so consider the statements obviously. Okay, so statement 1, in a seismograph, P waves are recorded earlier than S waves. And the second statement is, in P waves, the individual particles vibrate to and fro in the direction of wave propagation, whereas in S waves, the particles vibrate up and down at right angles to the direction of wave propagation. Right? So in this, you had the option statements as, okay, let's do it in a simple way. So, which is correct? 1 only, 2 only. But in options, it was that, I hope you understand how the statement based questions are. That statement 1 is correct, and statement 2 is correct. Statement 2 explains the reaction for statement 1, etc. But here, let us consider this. So, which of them are correct? So, I will launch a poll for this. I will give you 30 seconds, right? 30-second appears to be perfect time. So, let me know. Shriman, the class started at 12. Good. So majority of you have given the correct answer, but some of you have given the incorrect answer as well. So here, I'll show the leaderboard also. So few of you have given the correct answer, expectedly so. So the correct answer is basically C. Both 1 and 2 in this case are correct. Okay. So in a seismograph, P waves are recorded earlier because the P waves, they travel at a much faster pace. And why do the P waves travel at a faster pace? Because the particle movement is same as the direction of wave propagation. So the correct answer in this case is C. Okay. Now, after this, we move to the portion of the surface waves. What are these surface waves? How do they get generated? So to understand it is very simple that, for example, when we talk about this as a surface, let's suppose here you have the energy, which is, this is the portion of focus. So this is the portion of focus. So here basically, as the energy waves, they get transmitted, as the energy waves, these are the body waves, by the way, and as the body waves, they will get transmitted, they will impact the surface will get disturbed. Once the surface gets disturbed, then that surface will generate its own wave pattern, spreading all on the outsides, right? Spreading in the outside, and that is what is the wave generated on the surface, that is referred to as the surface wave. So surface wave has got its origin at the epicenter. Okay. Body waves, they have got their origin at the focus. Surface waves have got their origin at the epicenter. And all the destruction, devastation that we see around us, that is carried out primarily because of the surface wave phenomena in itself. So surface waves are those waves that travel on the surface of the earth. Here, let me write it down also. Originates at epicenter. At epicenter. Okay. Whereas the body waves, they will always be in origination, or they will always origin at the region of the focus. Now, the destruction caused by earthquakes is primarily caused due to the surface waves. On the basis of the nature that how they bring about, because once the surface is disturbed, it will not only end up vibrating in a vertical motion. Just like in the case of the P and S waves, we have observed that when the energy is released, the particles will vibrate to and fro as well. The particles will vibrate horizontally as well. So similarly, once the surface gets disturbed, the surface will vibrate horizontally as well as vertically. So based upon the type of vibration that is induced on the surface, here also, just like the body waves, you have the classification done into the Love wave and the Rayleigh wave, what is also the L and the R wave. Okay, so based upon the nature of movement, they are classified into two categories, the Love wave and the Rayleigh wave. Love waves, they are faster in comparison. In comparison. Okay. Rayleigh wave, they are basically slower. And all that you need to know is that it brings about a variation on the surface, in the sense that when we talk about the Love waves, they bring about a horizontal variation on the Earth's surface. The Earth's surface basically starts vibrating horizontally, whereas in the case of the Rayleigh waves, they end up vibrating vertically. Okay. So both of them, they are generated at the same time. So that is why when an earthquake occurs, you would observe that the land shakes in such a way. In case you have experienced the earthquake, the land shakes in certain way. You will observe some kind of a lateral movement as well, some kind of a vertical movement associated with it as well. Both of them are a part of the surface wave in itself. That is what is referred to as the Love and the Rayleigh wave. Okay. I hope that is clear. Please explain the right angle concept in S wave. What is the exact doubt that you have, Priya? If you could please summarize or pinpoint the exact doubt, I would be happy to solve that query that you have. But I want you to pinpoint that doubt, that in what portion of S wave do you have that particular doubt? Please let me know. Because I have already covered it in brief here when we talked about the fact that in the case of the S waves, when we talk about the particles, so here, let's suppose the particles are there in the S wave. So here, the first particle, in a sense, will be disturbed almost horizontally or vertically. Right? And then this is the direction of wave propagation. Direction of wave motion. Okay, so here, as the first particle is disturbed, it is always going to be joined by the second particle, because the particles, they are not freely floating. Any object, the land surface, inside the body, any state of matter, they are joined with each other in the form of bonds. So if the first particle ends up oscillating like this, it will disturb the second particle also. So the second particle will also undergo a kind of an oscillation that will bring an oscillation in the third particle as well. So here, the direction of the particle movement is what? It is perpendicular to the direction of the wave motion. And that is why when the particles, if all the particles, they are lined up like this, if all of them, they get disturbed like this, so the first particle might be present here, the second particle might come downwards, the third particle further down, fourth particle like this, and that is how the wave is generated. And this will keep on disturbing the next set of particles. Whereas in the other case, after some time, this particle basically might go up, right? Or it might, in a way, go down. It will disturb the other one. And that is how the vibration of the particles eventually will give rise to the wave motion in this. So that is what is the case of the S wave propagation. In the case of the P waves, the particles, they come closer and move away in the form of compression and expansion, just like how the sound waves move. And is that understood, or is there a doubt which still prevails? As I'll tell you that in case you are able to pinpoint your doubt, it will be much easier for you to understand as well, much easier for me to also be able to explain or remove those doubts, if at all, wherever they occur. And Ankit, both love and Rayleigh wave occur simultaneously. Yes, just like how P and S waves, they are created simultaneously, similarly like that. Mitali, are love waves slower in nature? No, love waves are faster as compared to the Rayleigh waves. But then, as compared to the body waves, the surface waves, they end up moving comparatively slower. Okay, as compared to the body waves, the surface waves are slower. Can you apply your logic that why that is the case? Why is it that the surface waves which are generated are generally slower as compared to the body waves? Can you think about the logic for that? Shrimant, I'm not able to recall. Should I revise first and then watch the recording? Always that should be the case. That when you have taken a look at the annotations, go through each and every PPT, whether you have understood each and every sentence in the PPT, whether you have understood each and every concept that we have talked about, each and every example that we have talked about. In case there is any issue, then take a look at the recordings. Distance factor from focus. They are perpendicular to the transmission of the wave. Surface waves are more destructive waves, that is correct. I'm talking about why is it that the surface waves are generally slower as compared to the body waves, generally. How you compare L love waves and S waves in terms of how do they travel, the speed of travel we are talking about. So this is the speed of seismic waves. So that is because of the fact that when we talk about the body waves, they are generated in the interior and they basically travel through materials which are having a higher density. Whereas the surface waves, they travel through the region of the crust. Crust has got the least amount of density as compared to the interior. So whenever the energy waves, they travel through materials of higher density, the speed of transmission is always going to be higher. That is why, under general circumstances, under normal conditions, the body waves are always going to move faster as compared to the surface waves. I hope that is understood. Okay. Why the name Love and Rayleigh? That is basically based upon the scientists, Alexander Love and Lord Rayleigh, who basically came across this particular discovery and the finding of these waves. It has got nothing to do with the romantic idea of love that you have, nothing to do with the kind of a story that you might be expecting, that it would have to do something with the two people falling in love and so on. No, it is based upon the individual scientist name. Okay, I hope that is understood. Right? Now, then we come across to the concept of the shadow zones. What are the shadow zones? Now, before introducing ourselves to this concept of shadow zones, I would want you to revisit what you studied in your class 8th and 7th standard science. And that would be, you would have studied about the portion of light traveling, right? Light traveling through different medium, what you understand by reflection, refraction, that is something you would have studied in your class 6th, 7th or 8th, whichever standard that is. Now you would basically have also gone through the fact that when you have the light which is moving through air, and then suddenly it moves into glass or water, for that matter, material of greater or a higher density, then basically the light bends, right? Again, from denser medium to a rarer medium as it travels, again, the light will end up bending, isn't it? This is something that we refer to as refraction. I'm sure all of you would have studied that earlier. So, what do we learn from this simple principle of refraction? That when light is a form of energy, after all, I hope we all are on a common ground with that, that light is a form of energy, that whenever energy moves through materials of different medium, it undergoes a bending due to the property of refraction. I hope we are all comfortable with that fact. Let me write it down, because very soon you won't be comfortable with this concept. So here, whenever light or energy travels through materials of different densities, it bends as it encounters varying densities. Okay, we are comfortable with this. Now let us bring this into application in a larger area. Now first of all, I'll ask you something very simple. If I ask you that the density of the region here at 1, and the, let's mark it as 1, the density of the region here at 2, will the density be similar, or will their density be different at 1 and 2? What do you think? Density, will it be similar or different? What does your logic tell you? It will be different. Okay. What about if we talk about 1 and 3 here? This is 3. So the density will be similar or density will be different in this case? What do you think? Here also it will be different, because we have seen that even in the region of the crust, it is not as if the entirety of the crust will have the similar density. On an average, we represent that as a density of 2.7 gram per centimeter cube, or 2.9 or 3 gram per centimeter cube. But it is not always going to be the same case. When you talk about the materials which are present closer to the surface, the density is very less. When we are talking about 30-kilometer depth, the density is much higher. So that means in the interior, as you traverse from one area to another, you encounter materials of different density. Now, with that concept, let us understand the behavior or the pattern indicated by these body waves as they move through the interior of the planet Earth, through the body of planet Earth. So here, let's suppose the focus is somewhere in this region. Okay, let's talk about the focus here. Now here, when the earthquake occurs in this area, body waves will be transmitted. Now, the body waves, will they be moving in the interior in a kind of a pattern somewhat like this. Or if I give you the alternative as the second image, will they be able to move in the body somewhat like this? Which of these images, image A and image B, which of them do you think is a more ideal depiction of how the body waves would be moving? Beautiful. It will be B. It will be the second case. Why? Because the body waves will be bending as they encounter, even within few kilometers, as the density of materials will change, they will undergo a kind of a bending. Natural bending will happen, and that means if there is enough bending, there shall be areas where they won't even be able to reach, right? Because there will be enough areas where these body waves won't even be able to reach. So, when an earthquake occurs, there are certain areas across the planet where, even with the help of the advanced seismographs, you won't be able to detect those body waves. And that is what is referred to as the shadow zone of the body wave. I will reiterate. Whenever an earthquake occurs, now energy waves or the body waves, they are released from the portion of the focus. So as the energy waves are released, naturally they go for some amount of bending. Why? Because they go through materials of varying densities at varying depth. That means due to this natural bending, there will be certain areas across the surface where you won't be able to detect any of the body waves whatsoever. Those are referred to as shadow zones. So if I depict it here in the form of the image in this, so here if you observe, this is the region of the focus. This is the region of the focus. So here, basically you will observe that the body waves, they are bending. Okay, they are basically bending. Now, in this case, observe it carefully. First of all, we'll observe the case of the P waves. How do the P waves behave? So here the P waves, when they originate, they will be moving in different directions. Now, as they encounter the outer core is in liquid state. So from a very dense solid, it is moving into a dense liquid. So the density will be different here. So they will undergo a kind of a bending. They will undergo a kind of a bending. Again, they will encounter solid. Again, they will undergo a bending. Here also, they will encounter a kind of a bending. Again, so. Again, they will encounter a bending as they encounter the liquid outer core. Again, so. Right. So, here you will observe as they are moving, they are almost moving straight. Why is it so? Because here, their speed further gets accelerated due to the solid inner core. We do know that the speed is very much dependent upon the density. The solid inner core will have the higher density, so it will accelerate. So here also, if you take a look at it, the P waves, they get bent. Here, as they encounter the outer liquid core, they will undergo bending, right? Again, they will bend like this. Here again, they will bend like this. So what does that tell you? That basically, with all the bending and all the movement, refraction kind of movement which happens, there are certain areas where the P waves, they won't be detected, right? Because of the natural bending and the interior structure of the planet Earth, there will be certain areas where the P waves won't be detected at an angle of 105 to 145 degree on either sides from the focus. This is the focus. So from focus at an angle of 105 to 145 degree on either sides, there are no P waves which are detected. So that is what is referred to as the P wave shadow zone. P wave shadow zone. Okay. But what about S waves? S waves will also bend. But to add to that, S waves have another property which is different from the P waves, and that is they are unable to move through liquid and gaseous medium. So when the S waves, they will encounter the liquid outer core. Whenever you will have the S waves encountering the liquid outer core, they will not be able to move beyond that because the outer core is in liquid. Liquid outer core. So the S waves won't be able to travel through that at all. So in this entirety of the region, you won't be able to detect any S wave whatsoever. So that region will be referred to as the shadow zone of the S wave. Shadow zone of S wave. Okay. So that is why, or that is what is referred to as a shadow zone. So, in brief, again, whenever an earthquake occurs, the body waves they transmit themselves throughout the interior of the planet Earth, and they basically undergo bending. Why? Because these body waves they will get deviated, they will basically bend as they encounter materials of different densities, and hence there will be certain areas across the planet where the P and the S waves, we won't be able to detect them at all. So those regions where the P waves and S waves are not to be detected, they are referred to as shadow zones. In the case of the P waves, the shadow zone is 105 to 145 degree on either sides of the focus. In case of the S waves, you have the shadow zone extending 105 degree from one side to the other completely. So that is what you have as the creation of shadow zone. Okay, is that understood, or is there any doubt which prevails in the basic concept of the shadow zone? Any doubts? No? Understood? Good. Kumari, you have also understood this? Good. Madhuri, in the case of S wave, please understand that S waves they are unable to travel through liquid. I hope that is clear. I hope there is no doubt in in that particular portion that S waves are unable to travel through liquid. Outer core is in what state? Outer core is in a liquid state. So will they be able to move through the liquid? Absolutely not. So here the S waves will dissipate in the region of the outer core itself, right? So that is why in this entire area you won't be able to detect any S wave because S wave won't be able to move through liquid, isn't it? That is why, unlike the P waves will be able to move through liquids, right? Because P waves are able to move through liquid, solid, and gases, all of them. So that is why you have the shadow zone which is created by S waves. In second image, S wave ray path, or is it P wave ray path? This is for S wave. This is for P wave. Okay, is that clear? Madhuri, please let me know. Or is there a doubt which prevails? Okay, it is clear. So I'll do one thing. I'll write it down so that it is clearer for you as further while you revise as well. See, understand this, that if the focus is here, let's suppose the focus is here. So the shadow zone which will be created will be at 105 to 145 degrees on either side of the focus, okay, for the P waves, and the entirety of the region for the S waves, because the S waves they won't be able to move through that liquid outer core. So that is why the S waves will be able to be detected. You will be able to detect them only in this region. Okay, so that is the concept of shadow zone. So let me talk about it, or let me write about the portion of it. So based upon this first deduction, that as it travels through materials of different densities, it bends as it encounters varying densities. Now, this leads us to the understanding or the aspect that when an earthquake occurs, due to the bending of the seismic waves or the body waves as they move through different densities, right? The There are portions on the surface where these body waves are not detected, and they are known as shadow zones. Now, we can also say that the shadow zone generated by the S wave is much larger than the shadow zone generated by the P wave. So S wave has got a larger shadow zone because S wave is unable to move through the liquid outer core. So S wave has got a larger shadow zone. Now, if you know the property of these P and S waves, for example, that is the speed that they will have, the different in case of different densities, so you will be able to calculate the time that they will take in terms of the magnitude of the earthquake. You will be able to formulate the time that is taken by them to reach the surface in certain areas. So with that idea, that we know the speed, we know the time taken, so we will also be able to furnish the idea about not only the distance that they have covered, but also the materials they have moved through. Because we will be able to chart out with the help of simulations the curve that these waves would generate. So that helps us understand the material densities which are present in the interior. And that helps us understand the interior structure of planet Earth. That is why seismic waves, they are one of the biggest sources of information when it comes to the ideation about the interior structure of the Earth and how is it that the interior basically has got different layerings associated with it. Okay, right? So that is basically the pattern of these the shadow zones. Now, when we talk about these earthquakes, generally whenever you have the earthquakes which are generated, so in a seismograph, if you detect it, so initially the rocks, when they start undergoing a kind of a motion, so there will be slight amount of shock before, or the slight amount of shaking before the actual earthquake occurs. That is oftentimes thought to be a precursor or an indicator of a major earthquake or a main earthquake. And that is what is also detected in a seismograph. So generally before an earthquake, when you take a look at a seismograph will indicate to you a kind of a motion, somewhat a brief motion before that, and then the major earthquake, and then after that, as the rocks they keep on settling into the place, there will be some motion on the ground surface even after that. So the shocks which have been experienced before the main earthquake, these are also what are referred to as foreshocks. Okay, the shocks which are experienced before the main earthquake, they are foreshocks. Then during the main earthquake, the shocks or the vibrations which are experienced, they are referred that is the main earthquake that we experience. This is the main earthquake. And then the shocks experienced as the rocks they settle themselves into the final new position, which occurs few days, few hours, even up till few months after the main earthquake. These are what are referred to as aftershocks of an earthquake. So, with the help of this study of the foreshocks, the main earthquake shocks, as well as the aftershocks, we are able to decipher what is present in the interior of the earth. By the way, it is this information which also helps us understand and the geologists to be able to pinpoint if there is a nuclear bomb detonation, etc., which is carried out. You would have heard about in global geopolitics that there are hidden nuclear tests, secretive nuclear tests which are done. Now, very soon after that, the world also gets to know that, okay, a nuclear test has been done. How do they get to know? It is with the help of these seismographs itself, right? Because these seismographs, they are installed virtually all over the planet. With the various different countries, they have basically installed these seismographs almost across the entirety of the planet. So here, whenever you have, for example, a nuclear explosion, which is, for example, when India carried out those tests in Pokhran way back almost 15 years back. Now, again, many of you would be very, very young to even have a slight recollection of that. But at that point of time, it was a big deal. It was a big news. And before the Prime Minister Atal Bihari Vajpayee could come on the podium and make that public media announcement, before that itself, the world had gotten to know that it was a nuclear test. How did they get to know? How is it that someone sitting far off in United States could get to know about a nuclear test which happened in Pokhran in Rajasthan? How did they get to know? It is because when you carry out these explosions, the earth shakes, the surface shakes, and that ends up releasing the body waves in the interior, which will be detected by the seismographs. In the normal earthquake, when it occurs naturally, the seismographs will indicate some foreshock, some aftershock. But let's say you carry out a nuclear explosion, then the seismographs will give you a kind of an unusual reading without any foreshock, without any aftershock, and that will help you understand that, okay, there is some artificial mechanism of shaking of Earth's surface which has occurred. So that is how we get to know about something which has been detonated way far away in India, something that is being detected in the region of America as well. So that is basically how the seismic waves, they help us understand the interior. They help us understand the mineral distribution in the interior, what kind of minerals are present, because we do know that the seismic waves, they will travel differently when they encounter materials of different densities. So by studying these seismic waves, analyzing them for years altogether, that leads the geologists and the scientists focus upon the areas that, okay, you might have gold present in the region around the core, you might have the presence of iron in the region of core. So that is totally dependent upon the movement and the speed of these seismic waves. For example, you would recall that we had studied about the Lehman discontinuity. Lehman discontinuity is present where? Let me see if we recall this. Where is it that the Lehman discontinuity? What is the Lehman discontinuity? Inner and outer core. Very good. No, it is between the inner and the outer core. Now, the scientist Lehman, basically, it is named after him. So basically, Lehman had carried out a study where he found out that as these seismic waves are traveling, their speed suddenly accelerates in the central portion of the core. So that made him conclude that there must be a region in the central portion which has got a higher density and which is solid, and that is why it has got such a property or such a kind of an influence on the seismic waves. So it is based upon these kind of conclusions, and the data of these earthquakes, they are studied for long years after the earthquake has occurred. They are analyzed thereby, and further after that, many other earthquakes were also analyzed, a similar pattern was found, and that is when people came to a conclusion that, okay, this kind of an earthquake activity could have been created, this kind of a event in the seismic waves could have been created only if we have the presence of that solid inner core. That is how we come to a conclusion about the internal structure of the Earth's surface as well. Remember when we were talking about geomagnetism, we were talking about how the core has got certain bulges which also ends up moving from one region to another. Now, how do we get to know that? That the core has got a bulge here, and the outer core has got a bulge there, so the magnetic pole is shifting. It is again with the help of these seismic waves. Okay, how do we get to know that? Okay, the magma chamber in this region is so full, it can give rise to a volcanic eruption. Again, with the help of seismic waves. Mineral distribution is studied. How? With the help of these seismic waves. Because we do know how the seismic waves will travel. At any point of time when an earthquake occurs, we know the focus. Thereby, we can always have a designation of what will be the shadow zones. Roughly 103, 105 degrees to 145 degrees on each sides of the focus in the case of the P waves, and 105 degree to both sides in the case of the S waves. Okay? Can earthquake be man-made? Absolutely yes. Parshuram, can we predict the shadow zones and affecting zones once the earthquake focus point is identified? Absolutely yes. And is wave travel faster in solid or liquid? Depending upon the density of the material, but generally solids is where it will transmit faster. In the case of artificial mechanism of earthquake, how we can detect the location where the test happened based upon the case of the sea. You would also have heard about the fact that, or if you are following any earthquake, when you find or read the news report from it, you will find that, okay, the US department has basically said that the earthquake in Nepal had a magnitude of 8.1. Now, the French meteorological department has given the prediction of 8. So, how do they get to know is because they detect these seismic waves. And based upon the detection of the seismic waves, they get an idea and they have multiple different observatories, right? So, if I can help you imagine that, if suppose this is the planet, now here, if let's suppose I have my observatories in all these areas, earthquake has occurred here. Now, it has taken some time for this observatory to record, some time for this observatory to record, some time for this observatory to record. So, by triangulation of the data, we will be able to pinpoint, okay, this had been the focus. So, if this had been the focus, energy has taken this much time to reach the epicenter, etc. By that, we can also conclude that, okay, this is the magnitude, this is the location. It is based on the triangulation of data. Okay. Can S waves also travel through asthenosphere? S waves, yes, because asthenosphere is not a complete liquid. It is neither a complete solid. It is a semi-solid. So hence, it will be able to move, right? But in outer core, which is a complete molten liquid, it won't be able to move at all. Do seismic waves have a standard unit? No. Earthquakes can be man-made? Absolutely yes. Okay. So now, after this, we come to what these earthquakes can lead to. So, earthquakes, when they occur underwater, they can lead to generation of very large waves on the water. And that is something that we refer to as tsunamis. Tsunami is basically Japanese for a giant wave. So those tsunamis, they are generally triggered due to massive underwater earthquake. Generally triggered due to massive underwater earthquakes. Now, before that, a simple question I want you to apply your logic to. So, if let's suppose this is the region of the land, here let's suppose I have oceanic water. Okay. Now, if I ask you, what would constitute the surface of the planet? Will that be A here, or will that be the top of water body, that is B? Let's suppose this is an ocean. What would constitute the surface of the planet, A or B? What do you think? Very good. Himadri, Ankit, Pavni, Karan, Parshuram, Sidhu, Madhuri, Sridevi, Kambapati, correct. Join correct. Shakti, correct. So basically, the surface, when we talk about it, surface will be A here. B will not be regarded as the surface. B is simply water accumulated. Okay, so B is accumulation of water. Think about it. If I hold palm of my hand here, if I make a kind of a hollow here or a kind of a depression, I put some water here. So my body's exterior, will that be the water surface, or will that be the skin of my hand? It will always be the skin of my hand, which will be the outer extent of the body. Water which is accumulated is a mere addendum to it. It won't be considered as a part of my body's surface, isn't it? The skin will be my body's surface. So, in a similar manner, always A will be regarded as the surface, not B. B is not the surface. Get that concept very clear. Now, once you have understood that, now let us understand what actually happens, which generates a kind of a tsunami. So whenever you have an underwater earthquake in event, so let's suppose you have two different oceanic crust, or not only two different oceanic crust, maybe an ocean and a continental crust in any of the ways. But wherever, let's suppose there is some subduction which is happening, some amount of convergence which is happening. Now, this convergence will never be smooth. This convergence, not only will it be rough and random, it will also release a lot of energy in the process. So here, let's suppose at a depth of 60 kilometers from the surface, here there has been resistance which has been overcome and energy has been released in the process. Now, when that energy has been released, that energy will disturb the surface. This is the surface, isn't it? So that energy will disturb the surface. Once the surface is disturbed, the water on top of it, that will also be disturbed, right? If let's suppose you have a mug of water and a plastic mug, for example, now the base of that mug, if you hit it up, if you disturb the base of the mug, what will happen to the water? All that water will be disturbed as well, isn't it? Some of the water might spill out as well. Why? You have not touched the water, you have simply disturbed the base of the mug. So that means if you disturb the surface, water on top of it will also be disturbed, isn't it? So the water here on top of the region of the focus, that will get disturbed. And once that gets disturbed, water will move in wave like, that disturbance will move in wave like pattern in almost all sides, and that generates what is referred to as a tsunami or a giant wave. So all that giant waves, they get disturbed, they get created because of the underwater earthquake creation or the occurrence of these underwater earthquakes. For example, 26th of December 2004 is when you had one of the most massive tsunamis to have occurred in the recent past in the region of the tsunami actually hit the eastern coastline of India, some parts of the southern coastline, Maldives, Sri Lanka, Andaman Nicobar, Indonesia, all of them, they were completely devastated. Why? Because there was an underwater earthquake which occurred near Sumatra. And there you had an oceanic convergence. And that earthquake, which was triggered because of the convergence, that disturbed the water. And that water which was disturbed, that traveled in all direction and caused that tsunami. Then when we talk about the March tsunami, which occurred in Japan, now, there, due to which the Fukushima nuclear disaster, everything happened. Now, that was again triggered because of the subduction of the Pacific plate. As the Pacific plate was undergoing subduction, it triggered an earthquake, and that earthquake, that generated a tsunami. Last year, that is in January 2022, 15th of January 2022, you had one of the most massive volcanic eruptions to have occurred on the planet in the past few years, and that was the Tonga eruption. The Tonga eruption was so massive, Again, Tonga is a region in the southern Pacific, Tonga Islands. Now, there it was a kind of a volcanic eruption, which also the eruption was so massive it generated an earthquake. As the molten materials they tried to push up to the surface, it created an explosion, it generated an earthquake. That earthquake, which was generated in the southern Pacific, now it disturbed the water of the Pacific, created these large waves, which traveled all the way from the Tonga Islands to across the Pacific to the region of South America. It claimed two lives in the coastline of Peru. So that also tells you that the waves which are generated, they can travel for a very long distance and they can create their own set of damages. Okay? If the oceanic crust is older, its density will be more. Yes. Does observatories also in ocean surface to read such tsunamis epicenter? You have some observatory ships which are consistently in motion. They have the scientific equipments. They do carry out the process. The waves in the sea are generated because of the oceanic crust of the moon. No, the normal waves in the sea, they are generated because of the wind movement. But the waves, they can be generated anywhere, everywhere, because of various conditions. So once you have these earthquakes, massive waves are generated, and that is a tsunami. Why does the water recede from the shore before a tsunami? So this is a most common and a general. So whenever I talk about these, I get two of the very basic questions frequently: that are animals able to really detect, understand the tsunamis and earthquakes beforehand? And second, does the water recede? So is that a kind of a heavenly warning for us before that? And fair enough. Basically, why does the water recede? Water doesn't recede significantly. That is a mere misconception. Please understand that when you have, it does recede slightly so, but that is the activity of a wave. How does the wave travel? When you talk about a wave, how does the wave travel? So, if I were to think about it like this, let's suppose this is the surface. Now, here, a wave is generated, a large wave which is moving. Wave is what? Wave is where the water in this region in itself, they will be disturbed. I hope we are very clear with the fact that wave is not the forward movement of water. Wave is where in the same region water moves up, goes down, comes back, moves up, goes down. So we will study later on that water movement in the case of the wave is like a circular oscillatory motion where the water is lifted up, it moves ever so slightly, comes back. And then that movement is observed in the next particle of the water. And that basically means the wave will move here. Whereas in the earlier portion, the water as it has come down, it basically will have a kind of a trough, and the risen portion is the crest. That is how we see that the wave movement happens. General perception is when we observe a wave, we think that water is being carried for longer distances. That is not the case. It is the water which is getting disturbed, and it basically ends up disturbing the water as it moves along. So here, when we come to this particular region, let's suppose here, so as the water in this region undergoes that kind of a swell and a fall, so that basically means in that swell, some amount of water from this region will also be consumed in that swell. So on the ground surface, people basically think about it as a kind of a receding of water, but that is not the case. It is simply the circular oscillatory motion induced in the water which generates that waves. Is wave due to the attraction from sun or rotation of earth? Because of both. Attraction of moon is the major cause. When a seamount is created, at that time also these kind of wave is generated or can create tsunamis. Underwater volcanic eruptions, they have the potential to create the waves. Yes, underwater volcanic eruptions, if they are massive enough, if they can trigger the surface, if they can disturb the surface, they can always generate a wave. Why not? Can tsunami and volcanic eruption happen simultaneously? A massive volcanic eruption can lead to the disturbance of the surface, which can generate a tsunami always. Please understand, tsunami is triggered due to the shaking of the base of the ocean. If that base gets disturbed, any kind of vibration, the water above it will also be disturbed. And when you disturb the water, even a bucket of water, when you disturb it, it travels in the form of ripples outwards, isn't it? If I take you back here in this particular portion, if I can take you here. So you are disturbing the water in this region, but there is a ripple movement which happens in all the directions. So is it the case that water from here travels outwards? No, water is simply moving in this region itself, but that is disturbing the water next to it. That is disturbing the water next to it. That is disturbing the water next to it. And that is how you have the ripples which are created, isn't it? So if you simply implement it on a larger scale, think about it as if this water is disturbed due to the underwater movement of the surface. So that basically means that there will be generation of these large waves which will move in all different directions. Okay, right? What is a tide? Tide is the vertical variation that you observe in the height of the sea water or the ocean water, which is created due to the attraction of the moon. That is why attraction of the moon and also the centrifugal force of the planet Earth, that is what generates the vertical movement. And Srimant, your question is wave is due to the attraction from sun or rotation of Earth. Wave is purely because of the wind motion. Is that understood? Any doubt which prevails? No? Good to go? Fair enough. Now, after this, we move on furthermore to look into the geographical distribution of earthquakes. And from here, frequently you have mains type of questions which are asked in this area that discuss about the geographical distribution. Now, where is it that the earthquakes will occur? Why waves are high during the new moon? Waves are not high during the new moon. Tides are high. There's a distinction between the waves and the tides. I would urge all of you, let us wait till we come to oceanography. There we will cover waves, there we will cover tides. The reason for that, because as of now, many of you have no clue about what a wave is, you have no clue what a tide is. Many of you are simply confusing wave and tide with each other. Tide is when the level of water simply goes up, goes up during maybe 12, goes down during 6 p.m., again 12 at midnight, it will go up. So that is because of the rotation of the planet on its axis, the attractional pull of the earth as well. The waves that you see, that is different. Right, that is generated due to the wind movement. We will come to the portion of oceanography because as of now, many of you are simply shooting arrows in the dark. Let's not do that. Let's attack the concepts. When we come there, we'll talk about it. Now, the geographical distribution of earthquakes. Now, how is it that the earthquakes, we can think about it, that where do they occur? Will the earthquakes occur randomly everywhere? No, they won't. Right? Very good, Pavni. So generally, you will observe the earthquakes to be occurring across the plate boundaries. Generally, in most of the cases, across the plate boundaries, or in certain cases where maybe there is a crack which has opened up and there is some distinct movement between the two regions, there also sometimes maybe an earthquake can occur. But generally, in most of the cases, yes, Shriman, good. So, majorly across plate boundaries. Now, this can be convergent, divergent, as well as transform. Convergent, where the two plates are colliding with each other. Divergent, or even transform, where they are moving parallel to each other. Now, out of the earthquakes occurring across these plate boundaries, if you apply your logic, where is it that the least intensity, least magnitude earthquake will occur? Convergent, divergent, or transform? Where is it that you think that the mildest and the least magnitude earthquake is going to occur out of these? Beautiful. Himadri, Kambapati, Shilpa, Niranjan, Ganesh, Satyanarayan Good, Kumari correct, Suganti correct, Sidhu correct. So here you will observe the least magnitude, least intensity earthquake occurring across the divergent. Across the convergent and transform, you will observe the stronger earthquakes which will occur because they are trying to move against each other. They are trying to overcome the resistance of each other. So the energy which will be released in convergent and in transform will be massive. Whereas in the case of divergent, the land is already trying to move away from each other. It is only the volcanic portion, as the magmatic material tries to emerge out of the surface, it is only that portion which is going to create some amount of seismicity. Otherwise, the land is trying to move away from each other. So that is why you will have mild or minor earthquakes across divergent, very strong earthquakes across convergent and transform boundaries across the entirety of the planet Earth. It is true that earthquakes, even though they can occur in any part of the world, but in areas of folding, faulting, wherever you have the crust which is weaker, frequency of earthquakes is more than anywhere else. So across the world, you can divide the zone or do go for the zonation of the earthquakes in two major zones where the earthquakes will be very frequent. One is the circum-Pacific earthquake belt. Now, the Pacific Ring of Fire, basically, that is where you have convergence. We have seen that all around the Pacific, you have convergence or the transform plates which are in existence, and that convergence is caused why? Oceanic or oceanic continental, that convergence, right? And then you have the Mediterranean Asia earthquake belt, which is also referred to as the Alpide belt. So, in that region also. Why? So, let us take a look at that. Okay. As soon as I finish the earthquake, I'll give you a 10 minutes break. Okay, Himanshu. So I hope we are able to withstand that because I don't want to break the flow again in the middle of the earthquake portion as we are discussing. Or do you want a break right now? What do you think? Should we finish the portion of earthquakes? Let's finish it up and then we will talk about it. Okay, good. Now, here, when we talk about these regions of earthquake, I want you to focus on the areas where the earthquake is occurring. Now, this is a particular map which will be of quite greater significance for you. This is not something that you will find in your textbooks, let me assure you. This is not something that you find in your reference books. This is a map which gives you an idea about the various different plates, minor and major, and where is it that the earthquakes are occurring around them. So if you observe, look at the broader picture, zoom out of sorts. So the earthquake which is occurring in this region, the region where I'm marking it up. Now this earthquake, will it be minor earthquake or will it be major earthquake? What do you think? Will it be minor or will it be major? Beautiful, perfect. It will be minor earthquakes. Why? Because it is a divergent belt. We are talking about the mid-Atlantic ridge, right? Now look at the region around southern part of Italy and Mediterranean. You would have frequently read the news stories, even if you don't recall it right now. But in the past 4 to 5 years, Italy has suffered from a massive earthquake, causing a lot of devastation. The region around here also, earthquake has occurred in very recent past. That is in the region of Libya, Morocco. Then here also around the region of Turkey, Syria. Now, why is it that these regions experience so heavy earthquakes? Because there is convergence. In this case, here when we talk about the region of Mediterranean, when we talk about the Mediterranean region, basically we do know, we have talked about it, that the African plate is moving northwards. As the African plate is breaking, observe here also, observe this region. the East African Rift Valley. Here also earthquakes are occurring, by the way, but they will again be minor in nature because the African plate is already trying to break into two, so it won't be a major earthquake. But as the African plate is moving northwards, it is pushing the Mediterranean in a very similar way how Indian plate was pushing the Tethys Sea. In a very similar manner, even though the speed of movement of African plate is very slow, but still it is pushing the Mediterranean plate in the same fashion. So that is why in the southern portion of the Eurasian plate, you will observe that the Mediterranean plate is undergoing subduction. Now, whenever that process will happen, it will never be a smooth process. It is a convergent boundary. It will now here, along with the convergence, we have the oceanic convergence or the oceanic crust convergence, the Mediterranean Sea crust. So, whenever oceanic convergence happens, along with earthquakes, we have seen that we also have volcanic eruption. That is why here across this portion of Mediterranean, you will also observe frequent volcanic eruptions to occur. Okay, and here also recently you have observed the earthquakes. Why? Because it is the African plate which is pushing northwards. Now this extends all the way across the region of the Arabian plate as well. Arabian plate as well, right? Observe this region, that is the area of Gujarat. Here you have the boundary zone between the Indian plate, Eurasian plate, and the Arabian plate. Now, Arabian plate is in disturbance as of now. Arabian plate and a minor portion of Arabian plate, which is here, which is regarded as the Anatolian plate. Anatolian plate is a minor plate. Now, that is in motion. That is why Anatolian plate and Arabian plate's movement that has led to the earthquake in the region of Turkey and Syria, which was so very devastating. If an earthquake of that magnitude of 7 plus has occurred, means there was a lot of deformation, lot of energy which was trapped as the plates could not move. So the Arabian plate has moved a bit. If the Arabian plate has moved, that means there's a probability of movement of the Indian plate along with that as well. Indian plate will move. If the Indian plate moves ever so slightly, tries to adjust itself in the entirety of this region, massive earthquakes around the region of the Himalayas, massive earthquakes will occur. It has occurred, right? Recently, that is couple of days back, you had a massive earthquake here also in the region of the Philippine plate. So overall, if you do go for the zonation of these earthquakes, they will either occur around the entirety of the region of the Pacific, right? Or in the region around Mediterranean Himalayan belt. This is where the earthquakes are mostly concentrated. However, having said that, the tsunami, this December tsunami of 2004, right? 26 December 2004, the Indian Ocean tsunami, that occurred due to an earthquake here. So even this region, understand, whenever the Indian plate is in motion, this region might also undergo some kind of deformation, some kind of tension might build up here also. So chances are that in the near future you will experience an earthquake in this area as well. This is very much considered to be the part of this entire zone. So these are the areas of convergences. So wherever you have convergences, massive earthquake will occur. Here, however, this portion, observe this particular portion. I am coloring it with yellow. I will rub it out now so that you are able to observe this. So this is where you have a kind of a transform fault which is building up. So here also sometimes massive earthquakes are triggered around the region of Canary Islands. Here, then furthermore, around the Caribbean plate. Here also, basically as a North and the South American plate, they are moving westward. The Caribbean plate is getting squished. So in some small portions there is transform, in other portions there is a kind of convergent boundary. So that is why Haiti, Cuba, these areas, Bahamas, these areas, they experience very frequent earthquakes as well. Okay, so that is how you can basically go for the zonation of earthquakes. Let me tell you what kind of question will be asked from this area and what kind of basically answer is depicted or expected out of you. So the basic question will be that what are earthquakes, or which are the earthquake regions in India? Discuss about the global distribution of earthquakes. So it will be generally in the form of discuss or elaborate, right? So there, while you have to talk about the fact that the earthquakes can occur virtually anywhere, wherever there's a crack or a fault line across the surface, but generally, looking at the frequency and intensity of the earthquakes broadly can be summarized to be happening in two of these zones, Circum-Pacific Belt as well as the Mediterranean Asia or the Mediterranean Himalayan Belt. Now, in each of these, you have to discuss about the fact that why the earthquake is happening. In the Circum-Pacific Belt, it is happening because of the continental oceanic and oceanic convergence. In the case of the Mediterranean Himalayan belt, it is happening because of, again, continental oceanic in the region of Mediterranean and continental in the region of Asia. This is the reason why you would experience so very frequent earthquakes happening in the region of Iran, for example, very frequent earthquakes. And that has got its disturbance Iran, Afghanistan, Jammu Kashmir, Pakistan. So the entire region is experiencing earthquake. Why? Because the land is pushing into each other, right? So whenever there is a deformation, there will be a release of energy as the land tries to regain its natural shape and size. Is that clear? Or is there any doubt which prevails? So that is your geographical distribution. If you have a straightforward question of 15 marks, generally the question from this is asked in 15 marks. It is asked both in optional and GS. The question type and the pattern is the same. In optional portion, you are expected to talk about it in a greater detail. In GS, the simplified form will do. If you have only a 15 marker question about explain the geographical distribution of the earthquakes, which UPSC has asked previously multiple times, so there, ideally, the entirety of the competition that you will face, they will be concentrating upon only these two belts, Circum-Pacific and the Mediterranean Asia. So there, in order to gain advantage, I would always suggest to you that discuss or bring about this brief map, rough map of the plan of the globe, very rough map, and then also talk about minor earthquakes which occur across the region of divergence, the minor earthquakes which occur across these divergences. So that also will further add authenticity and weight to your answer. It will distinguish you from the general competition who has all read the same NCRT, who has gone into the same exam hall. So that is where you can bring about your additional source of information and you can complete your answer. Okay. Suganti, can you share separate image of convergent, divergent, and transform? Hmm. So in one particular map, you want only the convergent boundaries. In one particular map, you want only the divergent, and in one particular map, you want only the transform boundaries. Is that clear? Is that the requirement? Okay, so that map is not available. Kindly take a look at the map that we had discussed in the previous session, where we had discussed about the plate boundaries and the plate movement for each one of them. And that accordingly, the direction is also marked there, so you can form your own conclusion. Okay. Which country has witnessed most from earthquake? Which country has witnessed most, which has experienced most of the earthquakes? If that is the question you are asking, Gaurav, then it is not country specific. Earthquake basically historically has been occurring, has been happening underwater also. So you can argue that many of the regions, for example, Philippines, if you consider the areas to the east of Philippines, they are frequented by many earthquakes. The region around here, around Indonesia also, around Japan also, very frequent earthquakes that have occurred. Shrimant, I still did not understand why they are surrounded around the continents. Hmm. So, continents, when you talk about here, Shrimant, it is not always the case. Do you find any earthquake happening around the region here? Do you find any earthquake happening here? Do you find any earthquake happening here? If not, why so? Do you find many earthquakes happening here? Here? Why so? It is not the one which is surrounding the continents, it is the plate boundaries. So again, I would suggest both you as well as Suganti kindly take a look at the image that we talked about in last weekend when we discussed about the plate tectonics. Look at the plate boundaries. These are all the plate boundaries. This is the plate boundary of the Indo-Australian plate. This is the plate boundary of the Indo-Australian plate. This is the plate boundary of the Eurasian plate. Almost. This is the plate boundary of the North American plate. This is the plate boundary of the South American plate. Right? This is the plate boundary of the African plate. So it is not happening across continents. Rather, I would argue it is happening across the plate boundaries. Is that understood? Okay. Or is there a doubt? Ganesh, please explain landmass name on above part of the Arabian plate. Are you talking about the Anatolian plate? Anatolian plate is a minor plate. Okay, Anatolian plate is a minor plate which is present in this region around the. It is named after the area Anatolia. Anatolian region is present in the region around Syria, Turkey. It is based on that you have a minor plate, that is the Anatolian plate. It is a minor plate. Anatolian plate. Okay, I hope that is understood. Good. On what basis? Yes, Pavani, based on the size, right? Transform plate boundaries. Transform plate boundaries, Karan, are when the plates they move parallel to each other. When they are neither moving away nor moving towards, they are moving parallel. For example, here you have the Eurasian plate ever so slightly moving like this, African plate ever so slightly having this motion, but there is the rate of motion is different. So that is why you will have a transform plate present in this area. Okay. Now, Zagros is called a thrust and a fold mountain. That is because the creation of a fault in that region that has created that kind of a thrust fault. Now, thrust is created whenever you have a fold or the deformation which happens beyond a particular limit. That is when it breaks. The land breaks. So that is what creates a thrust. Now, that thrust can lead to the pushing of the landmass above the normal surface. And when that landmass starts to rise based on the creation of a block kind of a movement, then if there is a compression due to the movement of the Arabian plate here, that is why in the region of Iran, there you have the combination of both that thrust and the compression creating the Zagros Mountains. Okay. Now, then we come to the portion. So here observe across these plate boundaries, these are also accompanied by frequent volcanic eruptions. Other than the region where you have continental convergence. So other than those areas where you have continental convergence, all the other areas you will find the oceanic convergence wherever it is involved, it is accompanied by volcanic eruptions as well. Now we come to the earthquake zones of India. In India, basically, the earthquakes, they are largely concentrated in the region of the Himalayas, okay, and also in the region of Gujarat. In the region of Himalayas also, the probability of an earthquake which has occurred or the causation of the earthquake is very maximum, very high in the eastern region. In the northeastern region, the probability of occurrence of earthquake is very high, along with the region of Nepal, the region here. Bihar, also northern part of Bihar. Now, there you have significant amount of compression in the rocks, and that compression is created because of the Indian and the Eurasian plate colliding with each other. You have various different massive earthquakes which have occurred. For example, recently you had the Kathmandu earthquake in Nepal. Before that, you had the occurrence of the Kangra earthquake also, then Assam earthquake. Then, if you go back, one of the most massive earthquake in the region was the Darbhanga earthquake in Bihar, way back in 1934. That basically almost upended the entire region, created a lot of devastation in the process also. Then Gujarat also, here because it is at a plate boundary. It is a plate boundary of Arabian plate, the Indian plate, and the Eurasian plate. That is why any movement here happening, that leads to readjustment of the surface. Rocks, they come up, they can undergo subsidence as well. Regions historically in this area, they have gone underwater as well. Few of the areas have emerged above water as well due to the movement, the push and pull. And that is why you have these areas frequented by earthquakes. It is said, in fact, that due to the compression, the amount of deformation that the rocks have experienced and the rocks have gone through in this entire Himalayan belt, that amount of deformation is so very high. It will take many of the massive earthquakes to the tune of 8 to 9 magnitude for the rocks to be able to come back to their natural circumstance and their natural situation. So, based upon the intensity of the earthquake, based upon what is the frequency of the earthquake, you have the classification of this area from zone 2 to zone 5. Zone 1 is not there, zone 1 is absent. And that is primarily because of the fact that no area is absolutely free from the probability of an earthquake. Wherever you can have a kind of a fault, a kind of a crack created, there you can have an earthquake. Hence, this classification is basically zone 2 to zone 5, which is done. Now, then we come to the induced seismicity or the human induced earthquakes. These are basically the human induced or the anthropogenic caused induced earthquakes. Human induced earthquakes. Now, why do these human induced earthquakes happen? So, any of the human activities or any of the anthropogenic activities, if they will lead to the shaking of the Earth's surface, it will be regarded as an earthquake, won't it? So, here, when we talk about the various activities, you have to understand that you can have activities such as even hydrocarbon extraction. Hydrocarbon, that is drilling of oil wells and extraction of oil wells. Extraction of oil here. Let's talk about extraction of oil. Now, this extraction of oil, basically, here, how it is done. Generally, you will observe, this is just to give you a general preview of this. Generally, how is it that the oil is extracted? Basically, you will observe in this case. Let's suppose this is the ground surface. Now, how is it that the oil is present? Where is it that the oil is present? Generally, you will find that in this region where you have the presence of the rocks have oil perforated within them, contained within them. How do you extract oil? So, for extraction of oil, what you do is you basically carry out the digging where you will install the pipes. Right? You end up installing certain pipes in this region. Okay. Those of you who have worked in the petrochemical industry, oil extraction industry, you would be aware of this particular methodology. What is done? So, in from one of this pipe, what is done is that very high pressure water and air, very high pressure water and air is injected. So, very high pressure air and water is injected. So through this pipe, as that water or air at high pressure is injected, it will basically push all the materials in the surrounding region. Those materials will come to this area, right? They will basically then come for extraction. But many of the times, it is not a smooth process that here I am putting in air, here simply oil is coming like a petrol pump. No, that is not the case. That oil many of the times is present in pressure pockets. That oil is present along with a lot of gas as well. So when you inject high pressure air and water, this oil, while trying to come up, it might blast through the pipe with very high pressure. It might end up shaking the surface itself while it is trying to come out. So as the oil is being extracted, it oftentimes ends up shaking the surface, and that causes induced seismicity or anthropogenically caused earthquake in the process. Okay, so this is due to the extraction of oil. Wherever oil is being extracted in those areas, some or the other form of seismicity is observed. It is generally observed in the first stage. When oil flow becomes very smooth and natural, then you don't experience this. But when for the first time the oil is trying to get pumped out, that is when it will emerge with a lot of pressure, shaking the earth's surface, right? Then dams. So dams also, particularly the reservoirs of these dams, they end up also inducing these earthquakes. How is that? So here, let's suppose you consider this as the reservoir. Now, in this case, or the dam rather, now when you consider or when you construct a reservoir, it is basically consisting of all that concrete, cement, etc. Isn't it? All that cement and concrete, that is what makes up that dam. This is the dam. So that dam holds up all the water, huge volume of water. Now that water in itself will exert a weight worth few tons, thousands of tons. This concrete structure will also impose a lot of weight in terms of thousands of tons on the ground surface. So all that weight which is generated by here, all that weight which is generated, that can end up creating a crack of sorts. Crack can come into existence, or various cracks can come into existence. The rocks can get deformed owing to the pressure exerted from top. Furthermore, when you have this water, this particular water will also try to seep in. It will try to seep in through this area. It will try to seep in through this area. So in a way, it will try to lubricate that crack which is present. So when the crack is lubricated, what can we say about the motion of the particles? The motion will be further smoothened, and there will be a motion amongst the rocks. So due to the pressure, the rocks can get deformed. Due to the pressure, cracks can get created. Due to the water, there can be movement on the cracks. Any of these processes which can happen can always lead to the movement across the Earth's surface, and that can bring about induced seismicity or earthquake. So here, example, you can take the case of the Koena earthquake due to Koena Dam. Koena is a tributary of which major river? Are we aware of this? Very good. It is a tributary of river Krishna. Good. So it is one of the major tributaries of river Krishna. Then you have the mining operations which are carried out. And mining operations in the sense that when you carry out underground digging, now for that mining, you need to install those explosives and you carry out controlled explosion. So whenever those controlled explosions are carried out, right, those of you belonging from the mining towns and the mining areas of the country, you would experience that on a daily basis, you have periodic explosions, controlled explosions which are carried out. Now, why is it done? To loosen the rocks, to let the rocks get looser, right? And there, After the rocks, they get broken. From there, the minerals can be extracted. So whenever you have those periodic explosions with the help of the dynamite, that also ends up shaking the surface. So here, basically, periodic explosions. Deep sea mining can trigger earthquake? No, because deep sea mining does not involve digging. It simply involves accumulation of materials. Any example of oil extraction causing earthquake? Yes, you have. Now please understand, these earthquakes, the induced earthquakes, will never be so massive. It will be minor earthquakes. So you have many such minor earthquakes which can get created, which have been created during the extraction process in Assam. So you can take that as an example. Why oil reserves are available in some parts of the world only, like Arabian Gulf, Persian Gulf, in Russia, US? Okay. Why, you give me the answer of the follow-up question, why coal reserves are present only in some parts of the world? I will give you the answer of this question. Why do you think that coal is found only in some parts of the world and not all across the world? Why do you think? Or why is it that gold is not found all across the world? Why only in some parts of the world? Right. So I hope you are understanding where I'm getting at. So basically, mineral distribution, that is never going to be uniform. Mineral distribution, it is not as if that the entirety of those minerals, someone was sitting on top, some supernatural being was there, that okay, some mineral here Kerala should also get some mineral. Okay, a new state is getting created, so Karnataka should also get some oil. Okay, Rajasthan deserves some oil. Now people in Bihar have gone through so much hardship, they also deserve some oil. Okay, let us give them some gold also. If mineral distribution would have been carried out like this, then all areas would have had equitable distribution of minerals. How is oil created? Oil is formed, basically the crude oil, the natural oil that you observe, that is getting created basically because those areas in shallow seas, in underwater, oil is created underwater, first of all. So basically you have the marine organisms which die, and then their deposition over a period of time of millions of years, hundreds of millions of years, they get compressed, right? And that compression of those marine resources, of the marine species, that turns into crude oil and natural gas. So those areas which have been historically underwater, and those areas historically in shallow water, that has been observing the formation of oil. Even in India, you will find oil in the region of Rajasthan. Even in India, you will find oil in the region of Gujarat. Even in India, you will find oil in the region of Krishna Godavari Basin. Even in India, you will find oil in the region of Assam across Brahmaputra Plains. Even in India, you will find oil across the region of Arabian Sea in the Bombay High. Right? Across the world, you will find oil in Venezuela. You will find a lot of oil in the region around Arctic. So that is how oil is created. Okay? It is not as if that someone is doing injustice to it. Why the sea oil extraction not creates earthquakes? There also there also you have the creation of if even in the case of the sea, shallow sea, where you are extracting oil. See, it is not always that the hydrocarbon extraction will lead to earthquakes. No, in many of the cases, hydrocarbon will come out very smoothly. Very smoothly it will come out. In certain cases, it will not come out at all because of the huge pressure. There might be an explosion underground itself, blasting the pipe through which it had to come out, and you have to go through the entire process again. So there are various areas in which these hydrocarbons, they are packed in certain pressure pockets. And when you try to extract it, how do you extract oil? Oil is not extracted that you dig a well like water, you dip, throw in a bucket, you take out the bucket, you have a bucket full of oil. That is not how it is done. Even underwater, when you try to extract the oil, it is done by the similar process of drilling and extraction. So when that drilling and extraction process takes place, whenever you hit an air pocket or you hit a pressure pocket, that will lead to the shaking of the surface, and it will lead to earthquakes. Okay. Is that understood? Please explain a little bit. And also, we do not need to provide high pressure as shared by you in hydrocarbon extraction. As I told you, Priya, depending upon where that hydrocarbon is present, accordingly. So, for example, in Kuwait, in the early 1900s, in many areas of Middle East, a slight digging of the ground basically exposed oil. So, in that case, why would you need to provide high pressure? Right? But recently, last year, you would have heard about a news story where in Assam, around a new oil well which was dug, there was a fire which erupted, and that fire continued for many days altogether. Right? Why is that the case? Because it is not as if there is an underground pool of oil which is present. There is oil which is just like the groundwater. Oil percolates and is trapped in the permeable rock surfaces. So, oil in most of the cases is trapped within the permeable rock surfaces. Why is that the case? Because of how oil is created, how oil is formed. Oil is formed by the deposition of those marine species. Marine, that is the aquatic species, the which has remained underwater. So when they get solidified and when they get metamorphosed for millions of years, that is when the sedimentary rock pockets that are created, they will consist certain pockets of oil. In certain areas, natural gas would be present. So how do you extract that if it is present at a depth? So you go for drilling. In certain cases, when you drill, naturally the so much oil around it would be present that it would lead to extraction of oil. But in certain cases, you will have to push in air and water at very high pressure so that oil is expelled through the pipes, right? So that is very much required, regardless of the fact that you are saying that basically also we do not need to provide high pressure. We do need to provide high pressure in majority of the oil extraction. You have simultaneous digging which is done, right? In one of the pockets, you do provide high pressure air and high pressure in water as well. Okay, so even for the process of fracturing, the process of fracking that you talk about, there also you provide water at high pressure. So there, please rectify the concept a bit. Can nuclear disaster cause earthquake? Yes. Priya, is that understood, or is there a doubt which still is in existence? Please let me know. Current pressure pocket is basically referred to when you have pockets of natural gas, etc., which is trapped underground, which is consists of air of high pressure. So if you are not drilling it, it would be present here. But let's suppose if I drill it here, then that pressure will in a way become volatile. It will try to escape. So whenever it tries to escape, it will lead to shaking of the earth's surface. How dam causes earthquake? Because of the pressure induced, the weight induced from top. That is how dams will induce the earthquakes. So near a dam, there is always a possibility of an earthquake? Absolutely, yes. Absolutely. Always there will be a possibility of an earthquake. Any doubt which is in existence, any kind of doubt. Priya, is that understood? Kambapati, you have said it is clear. Karan, clear. Shrimant, clear. Kumari, about the dam, basically the weight of the dam structure, weight of the water imposed, all of that exerts that pressure, due to which the rocks not only get deformed, sometimes the rocks can develop a crack as well. And thereby, due to that, you can have movement within the rock itself, and that can induce an earthquake. That is what is also referred to as reservoir induced seismicity or the dam induced earthquake. This is also what leads to reservoir induced seismicity, because it is the weight of the reservoir which is creating that issue. So this is also RIS, that is reservoir induced seismicity. Okay, I hope that is understood and that is clear. Now, after this, we'll come to the portion of volcanoes, but before that, do you need a break? Let me know. Is the break required? Okay. So fair enough. We take a break as promised. So break of 10 minutes. I think that would suffice. So let's take a break of 10 minutes. Let's be back and let's study about the portion of volcanoes. Okay. A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. So now we come to the topic of volcanoes. So volcanoes or volcanic eruptions easily they end up presenting one of the most picturesque images across the planet. That is something which has captured the imagination of mankind for centuries and millennia altogether. Volcanoes in the early days were oftentimes thought to be as a kind of a wrath of God, that basically the gods have become angry and that is why the hell is let loose. It is only very recently, rather, that we understood the actual fundamentals behind the eruption of a volcano. That why does a volcano erupt? Where does it erupt? We have seen earlier also, while we were taking a look at the formation of planet Earth, that the planet went through the phase of degasification, which was responsible for the new different gases introduced into the atmosphere. And also that phase of degasification eventually indirectly also led to the formation of water on the planet Earth due to occurrence of rainfall. So volcanic eruptions have been responsible not only in shaping the atmosphere, they are the ones which are also responsible for providing water on planet Earth. So volcanoes are very, very important for planet Earth. The new land masses which get created, they get created due to volcanic eruptions. So molten materials from the inside, they are basically expelled along with all the gases. That is what we have as volcano. Now, when we talk about a volcano, basically it is, in simple words, a vent in the Earth's crust, a kind of a passage in the Earth's crust, through which heated materials consisting of gases, water, lava, fragments of rocks, they are ejected from to the surface. All these materials, they are basically ejected. Why are they ejected? Because of certain basic fundamentals. First of all, if you have molten materials present in closer to the surface, molten materials, they are lighter than the surrounding solids, so they will always have a tendency to rise up. All the molten materials, they will have a tendency to rise up. Along with that, the presence of gases. Now gases basically provide the pressure, and the presence of gases with the accompanying pressure, it brings the molten materials to the surface. Hence, presence of gases is very important. Of gases is very important to cause an eruption. Why? Because the gases induce pressure, and it is because of that pressure that materials, they are brought to the surface, which brings molten materials to the surface. So many of the times it does happen, and it has happened in the past as well, that you do have the molten materials which are present slightly in the interior, but then there is no gas which is accompanying that. So due to lack of pressure, the molten materials, they have started to cool down in their original place in the interior itself. And we have seen earlier that when the molten materials, they cool down in the interior, they form what we refer to as the intrusive igneous rocks, isn't it? We have taken a look at that. So that is how you have the creation of these volcanic eruptions. So gases are very, very important. By the way, a classification that we looked at in the previous week as well, when molten materials, they are present in the interior around the region of the magma chamber, that is when it is referred to as magma. When these molten materials, they come above the surface, that is when it is referred to as lava. Now, based upon how frequently an eruption occurs, based upon that, it is classified into active, dormant, and extinct volcano. Okay, so this is based upon the frequency of eruption. based upon the frequency of eruption. So active, as the name in itself tells you, that the eruption is very frequent, that the eruption can happen quite significantly at any point of time. So you have many examples. So generally you will observe that in the case of an active volcano, the magma chamber also has got a lot of molten material, presence of gases are also there, and you have a frequent eruption which is caused and which is experienced. Here example of active volcanoes, can we think about? So in India, you have only one active volcano which is present in India, and that is Barren Islands. So you can take the case of Barren Islands in India. In the region of Andaman Nicobar Islands. Then Mount Pinatubo. Where is it present? Mount Pinatubo, Philippines. This is also responsible for some of the most explosive eruption which has happened in the past 2 to 3 decades. So these are examples of your active volcanism, where it has occurred, the volcanism has occurred in the recent past, within the 10-20 years in the past, and it can again happen in the near future. There's a probability of that. We cannot possibly estimate that when this eruption will happen, but it can happen in the near future. Then, when we talk about the dormant, where the volcanic eruption has occurred, maybe 100 years, 200 years, or 300 years in the past, but then there is a possibility of the eruption happening again 20 years or 30 years in the future. There is a possibility of that happening again, right? So that is a dormant. Dormant means sleeping of sorts. So it can rise up at any point of time. So dormant volcanoes, they have happened sometime in the past. There is always a possibility of them happening again. For example, Mount Vesuvius. Mount Vesuvius, for a long period of time, it was understood that it is extinct. But then in 78 AD, it basically erupted, devastated the entire population and the town around it. And that was recorded by the Roman historians. And that is how we got to know that, okay, this is something which has erupted. Now, again, for the next 100 years, for the next 200 years, there was an expectation that this volcano can erupt again. It did not erupt. For the next 500 years, there was always a folk tale that there can be a volcano eruption here, but it did not erupt. For the next 1,000 years, it did not erupt. It erupted 1,500 years later, again devastating the settlement which had erupted or emerged in that area. So these are examples of your dormant volcano. Example, one of these example of dormant can be taken as Mount Stromboli, yes. Other ones, Mount Stromboli. Also, if you think about, yes, Yellowstone, that is also a dormant one. Then Krakatau in Indonesia. In Indonesia, that is also a dormant one, where the last major eruption happened in 1880s. And the eruption was so massive that it is said that the explosive sound traveled as far as the region of Japan. Think about it, a volcanic eruption happening in Indonesia and the impact of explosion being felt in the region of Japan and Turkey. How far they are from Indonesia. That was the massive amount of explosion and the gases which were released during that point of time. It is said that it would take 200 years for the planet's atmosphere to digest the amount of carbon dioxide that was released in that Krakatau eruption. It brought about a tsunami, and the amount of dust that it released blocked the sunlight in the region for a substantial amount of time, for almost 2 months continuously. So this is dormant. Then we have the extinct, right? Vesuvius also. Extinct basically means where in both the case of dormant as well as in extinct, you would observe here something which is referred to as a plug. What is a plug? So basically, molten materials, they have solidified in the passage, in the vent way itself. In the passageway, you have the solidified molten materials. So in the case of the dormant one, if let's suppose large amount of pressure will develop, first of all, that pressure will have to break through that entire region of solidified igneous rock, the rock which has solidified in the passage. And then it would have to erupt out, right? So that is where in both of these you will find solidified materials in the passageway. Then extinct, no possibility of an eruption happening again. So here, no possibility of future eruptions. Example, Mount Kilimanjaro. See, with Mount Kilimanjaro, the thing is that you have three peaks there, right? One of them is considered to be extinct, but the other two peaks, there the last eruption happened close to around 180,000 years back. That is almost 2 lakh years back. But there is a probability of that eruption happening again as the East African Rift Valley becomes activated. So many portions, or out of the three peaks, two of those peaks of Mount Kilimanjaro are still classified under dormant. One of them is considered as extinct. Okay, right? And yes, Huascarán in Peru, that is one of those. Mount Aconcagua is also considered to be extinct, right? So Mount Kenya is also considered to be an extinct one. So these are the various examples. So one of the peaks of Mount Kilimanjaro you can consider. Of Mount Kilimanjaro. Kilimanjaro is the highest peak of Africa. I hope you are aware. It is situated across the East African Rift Valley, and that is why you have these volcanic eruptions which occur, right? Then, yes, Huascarán in Peru. Any other example that we can think of? Right? You have certain examples of extinct volcanoes, even across the evidences of them are also to be found across the Aravallis. Right, the northern portion of the Aravallis, you will find the evidence of extinct volcanoes there as well. Thielsen is one of those. Yes, good. Mount Thielsen is the example of that. Where is Thielsen situated? Do let me know. Benjita and Pavani. Oregon. Yes. Thielsen in Oregon. That is where you have the presence of a large caldera also, which is created. Something we'll take a look at later on. Now, this is basically based upon the frequency at which the eruption is happening. When we talk about the anatomy of an eruption, that how is it or what is it that the eruption exactly represents? So, whenever you have a volcanic eruption, it is always fed by an underground chamber of molten materials, and that is what is regarded as the magma chamber. That is regarded as magma chamber. It consists of the molten materials. Now, these molten materials, in the presence of the gases will provide the pressure, as we have talked about previously as well. So, the molten materials, they try to rise up. Molten materials being lighter than the surrounding solid, and also the heat, because of that, they will try to rise up. Now, here, they will try to rise up. Earlier, it is always one thing that you have to understand. Many of the times, the candidates, when they take a look for the first time at the anatomy of a volcano, they think that the volcano will erupt out of mountainous areas only. But that is not the case. If you take a look at the volcanoes, basically here, if you think about it, initially you have a vent which is created, a passageway, and then the materials, they rise up. These materials, they start accumulating. They solidify and they accumulate. Eventually, it is that continued accumulation which leads to the creation of a kind of a volcanic landform. right? So the future eruptions that you will observe, it appears as if it is emerging out of a conical mountainous area. But generally, the eruption occurs from gaps or the vents on the ground surface. Now, when this eruption occurs, it is not always going to be the case that all the molten materials they come out from the central peak. Many of the times, the molten materials they will spread themselves along the various different layers of rocks in itself as they solidify. Okay, some of these molten materials basically they will emerge out, they will solidify in between in various layers, forming and in a way a kind of intrusive igneous rocks are created as these molten materials they solidify in the interior. When the molten materials come out, along with them they bring small particles, small solid particles as well, and a lot of gases are released. Now, the gases which are released in that, in most of the cases, the majority of the gas which occupies this is what? It is basically the gases. Majority is water vapor. Very good. Kambapati. So water vapor is the major gas. Then you have sulfur dioxide. Beautiful. That is also released. Then along with that, you have carbon dioxide. All these are the gases which are released in large quantity in huge amounts. Okay. Whenever you have such kind of an eruption occurring. Now, why is it that a volcano occurs? Why is it that we experience a volcanic eruption? So, in majority of the cases, the volcanoes will occur wherever there are plate boundaries, right? Where that is where the crust is weaker. That is where the molten materials they find it easier to come out. So, majorly across the plate boundaries, majorly observed across plate boundaries. Okay. Now, along which plate boundaries do you generally observe these volcanic eruptions? You will observe it across divergent and also across convergent. But provided it has got to be a kind of an oceanic convergence. So, also across convergent if it is kind of an oceanic convergence. Wherever you will find the kind of an oceanic convergence, there you will find the volcanic eruptions to occur. Something that we have covered last week itself. In the case of the divergent boundaries, you have the kind of convection current in the interior, which leads to the volcanic material to be expelled out. Right. So that is the major area where you will observe. So majorly across the plate boundaries. In certain cases, it also occurs across the transform plate boundaries. That is observed across, for example, in the Canary Islands. In certain cases, even across transform boundaries. Why is it and how is it so? Transform boundaries basically where you have the transform fault which is present, transform fault which gets created due to creation of transform fault line of a transform fault. This is in certain cases, not always. Not always. Now, why is it so that this is observed, that this is basically witnessed? Convergent and divergent, we do know. Convergent, whenever you have an oceanic convergence, the oceanic crust, it starts melting, and then the molten materials, because the gases are also present, because some of the water would have also gone underneath. So the molten materials along with the gases, they come up across the divergence we have seen. Why and how across the transform plate boundaries? Let us understand that. So how can a fault basically refers to a large crack, sometimes lead to volcanic eruption? Not always, sometimes. I will stress it multiple times that it is not always the case that if a crack has occurred, there will be a volcanic eruption. But sometimes, definitely, it can lead to volcanic materials coming up. Why is it the case? That is because of the simple principle. When we talk about the melting point of materials, as we have seen in the case of the inner core. So, if let's suppose in a region, if there is a material which is present, I'm applying pressure from all sides. Okay, I'm not allowing it to expand at all. So in this case, the temperature at which this material will melt, that temperature will be high or low. So in this case, will the melting point be high or low? If the pressure is high, melting point will be high or low. What do you think? Good. Madhuri, Himadri, Sidhu, Kambapati, Parshuram, Ankit, Benjita, Abhishek, Gaurav. Perfect. So, if the pressure is high, which doesn't allow the material to expand, the melting point will also be high, right? Because it will take much higher temperature for the material to melt. So, melting point is almost related to the pressure. Higher the pressure, higher the melting point. So, in the interior, melting point is proportional to pressure induced. So if the pressure is high, melting point is also high. Now, let us understand the concept that why sometimes creation of a fault leads to the molten materials coming higher up. So here, if you think about any particular area, land surface, for example, let's suppose at a depth of 100 to an hour 150 kilometers, you have certain materials. Now, we have also studied that as we go into the interior of the planet, below the surface, the temperature increases, what we also refer to as a phenomena of geothermal gradient. As we go into the interior, the temperature will always increase. We have seen that. So here, let's suppose the temperature is 600 degrees Celsius. Let's also assume that for this material, melting point is 650 degrees Celsius. So if the melting point is 650 degrees Celsius, temperature is 600 degrees Celsius, will this material be present in a solid or a liquid state? Let me see if we are awake or not. Will this material be present in a solid or a liquid state? Simple. It will be present in a solid state because the temperature is not as high as it is required for the melting to happen. Now, here, this will be in a solid state. All those who have given liquid, semi-liquid, it is incorrect. This will be in a solid state. Melting point is what? The temperature at which the solid will get converted into liquid. That is the melting point. But here, this material requires a temperature of 650 degrees Celsius to get converted into liquid. But the surrounding temperature is only 600 degrees Celsius. Hence, it will be in a solid state. Now, let's suppose if I can take you back a few slides, if I can take you back into this particular PPT, let's suppose there is a divergent movement of the plates happening here. and that has created a transform fault in this region. Now, that transform fault which gets created has been created recently as you have the plates trying to move with respect to each other. So, when you have a fault, you not only have a large crack which is created, but also land moving with respect to each other. So, let's suppose you have the development of a crack or a large fault. Now, when a crack develops on the ground surface, on this material, can we say that the pressure will be same as before, or will we say that the pressure has increased as before, or will we say that the pressure has reduced as compared to earlier? What do you think will be the situation here? Has the pressure been same, has it increased, or has it reduced? Perfect. Correct. See, understand, here you had the pressure being exerted by the ground surface, but now the ground has developed a crack. So the amount of pressure exerted, that will reduce, isn't it? So when crack develops, a crack develops, pressure exerted on the interior reduces. As compared to earlier, the pressure will reduce. Now, when the pressure reduces, we do know that the melting point will also reduce, isn't it? So, melting point of material also reduces. Point of material also reduces. Now, let's assume that the melting point has reduced to 590 degrees Celsius. Let's assume melting point reduced to 590 degrees Celsius. Now, if the melting point has reduced to 590, we are just taking it as an assumption, and the surrounding temperature is 600. This time it will melt. This time it will get converted into liquid. So not only will you have the presence of the molten materials, along with that, all the gases which will get created, they will add to the pressure. And the molten materials, the liquid materials, they will try to come out through those cracks. They will create volcanic eruption. But let's take the case where the melting point does reduce, but the melting point has reduced to only 10 degrees Celsius. In that case, it is still higher than the surrounding temperature, so no volcanic eruption. So only in those areas where as the melting point reduces, it reduces to at least the surrounding temperature or even lower than that, only then the materials get converted into liquid and they start to rise up. So in this case, materials will melt and rise up. Is that understood, or is there any doubt? Please let me know. Is this concept understood, that why only sometimes transform boundaries can lead to the creation or the eruption of volcanoes? Understood? Good, because this is something generally books don't cover. So whenever I come across any of those concepts, I will ask you multiple times. Any doubts which prevail, please understand that on the weekends, generally, you will have a better chance to ask any kind of question. That by any kind of question, I don't want you to be asking question that what will happen in the 2024 Lok Sabha election, not those kind of questions. The general kind of questions associated with preparation, any kind of question that you have, always feel free to ask. We generally get a more some larger amount of time to interact. Okay, if by some mechanism we stop it from coming up, then what will happen? Whatever measure that you are using to stop it, that will be blasted away. Please understand that whenever you have a volcanic eruption which occurs, somewhere to the tune of thousands of tons of dynamite, that much energy is released in the process. The amount of energy released many of the times, for example, the Krakatoa eruption which happened, it released the energy worth many nuclear bombs altogether. You cannot manage to possibly stop these volcanic eruptions, right? And example of such eruption, good, Ravi. So this eruption, this kind of eruption, we will find in the region around the Canary Islands. Canary Islands to the west of Africa. I want you to locate it in the map as well after the session. That in the western portion, northwestern portion of Africa, you have the Canary Islands. There, the eruption which is created is because of this particular factor. Can we use the so I will write it here. Example, Canary Islands eruptions. Then, Ankit, sir, then in convergence and divergence is independent from melting point concept. See, in the case of convergence, the concept of melting point comes in play when the materials themselves, they basically go at a depth of 160 200 kilometers in the region of asthenosphere. The temperature already is so high that the materials will melt. In the case of divergence, already molten materials are rising up in the form of the convection current. Already molten materials are rising up. So that is why you have those conditions. But then that reduction of pressure and the melting of materials, that comes into place when you have the fault lines. Okay. And Priya, when crack occurs, then does atmospheric pressure will also be experienced by the material? Then in case the material will experience will be more pressure? Not always. See, atmospheric pressure, in that case, if you apply logic, then larger crack is required for that atmospheric pressure to be felt. So here, the crack which appears, that won't allow substantial amount of atmospheric pressure to be added up in that case. Okay. But yes, in the case of divergence, sometimes you have that atmospheric pressure playing a role, but not in the case of transform boundaries. Niranjan, what determines the viscosity of lava? Will it be based on the convergent, divergent, and the transform boundaries? It depends on the material present. Silica is the material which determines the viscosity. We'll study later that when you talk about felsic, it is viscous. When you talk about mafic, less viscous. And Akash, why there are no volcanoes in Himalayas? Also, the convergence is happening. But here, Akash, you have to understand only oceanic convergence will lead to volcanic eruption, not a continental convergence. We have discussed it last week also. I had written it in the slide as well. If you take a look back at the PPT, we have given the 2 points why no volcanoes in the region of Himalayas. Because when you have continental convergence, not a substantial portion of the continental crust goes underneath. Some portion of it goes underneath, but then, for example, in the oceanic convergence, you have the some water also which goes underground, and that creates that water vapor which adds to the pressure, but not in the case of this particular continental convergence. And whenever continental convergence takes place, the crust becomes so very thick that even if some molten materials are there, they will find it impossible to break through the surface. Okay. And Abhishek, in which type of plate movement there is high chances of oceanic convergence and also divergence, obviously? Sir, we are dealing with the reduction of melting point of magma. Magma is in liquid state. See, ideally it is in solid. This is solid material that we are talking about. If it melts, if in that case it will melt, then it forms magma. If you have molten materials which are already present, then the eruption is totally dependent on if there is pressure available. Pressure, if it is available and the crust is weak, it will break through. That is why it is frequenting on the plate boundaries. That is why the eruption is mostly observed across the plate boundaries. Okay. But in case the material is solid inside, then there is no magma. Then there also sometimes magma formation can take place if there is creation of a crack. Because if there is a creation of a crack or a fault line, then immediately the pressure induced on that solid material will reduce. And when that pressure induced reduces, melting point will also reduce. So when this solid material's melting point reduces, it will get converted into molten material, it will get converted into liquid, and then depending upon the availability of pressure, crust, etc., it can rise up and form a volcanic eruption. Is that clear? Right? So this was a question. Yeah. Karan. Now, Kumari, I hope that is understood from your end as well, because your question was also very similar. Abhishek, your question I have also answered. Madhuri, the volcano is 400 degrees. The melting point is reduced or increased. I'm unable to understand the question here, my dear friend. Apologies for that. The volcanoes is 400 degrees. The melting point is reduced or increased. Madhuri, the melting point basically here, when we are talking about, this is associated with the pressure induced on top. Please understand, not in all the cases will you have the eruption because of this. Eruption also occurs because of creation of hot spots, mantle plumes, etc., which we will basically read about later. This is just about the regions where you have cracks which develop. In those areas, what happens? Otherwise, normally the eruption will occur across divergent and convergent. Oceanic convergence is where it occurs the maximum. Then divergence also, you have the mid-oceanic ridges which are created in the process. And also eventually you have the other processes, other activities such as hotspots, mantle plumes, which we'll study after the break. Okay. So now we take a break, and after the break we carry out, and then we will continue further with our discussion, and we'll move ahead with the portion of all these are basically endogenic forces. We'll complete it, and then we'll move towards the exogenic forces. So we take a break now, and it is 3:05. So we take a break till 3:45, and then we meet again. So break till 3:45. Okay. And we meet again.